Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem having been chosen from the same book, Modern Physics, by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay. A hydrogen atom in an excited state emits a photon of wavelength 95 nanometer. Nano standing for 10 to power minus 9. What are the initial and final states of the hydrogen atom? Okay. What are the initial and final states of the hydrogen atom? It means it relates to energy levels. Okay, dear students, now we are going to its solution, but before solution we will have to go through a few snapshots. Okay, these snapshots will provide a foundation regarding the solution of this problem, and these snapshots will explain the philosophy behind this problem. Okay. First snapshot is about energy of a photon. Okay, energy of a photon E is equal to hf, where h is Planck's constant and f is frequency. This alternatively becomes equal to hc over lambda. Here h is the same which was in previous step, that is Planck's constant. However, lambda is here wavelength and c is the speed of light in vacuum. Okay, now we are going to second snapshot. Dear students, this second snapshot is a table of physical constants in which a large number of physical constants are given. We will pick that physical constant which we may require. Okay, for example, dear students, here value of c, speed of light, is given. Similarly, value of Planck's constant h is given. Moreover, combined value of hc, that is after multiplying h with c, is also given here in this second last row on left column. Okay, we may take some other. Similarly, hydrogen ionization energy 13.6 electron volt. Okay, this is also given, and what the constant will be needed, we may take from here. Okay, next snapshot is about E naught is equal to mk square into e raised to the power 4 divided by 2 h cut square. Okay, dear students, here h cut is not simply Planck's constant, rather it is h cut or h bar or h reduced, which indicates Planck's constant h divided by 2 pi. Okay, similarly here k is not kinetic energy or something else. Here k is a constant 1 over 4 pi epsilon naught. Okay, E is elementary charge, charge of an electron or charge of a proton, etc. Okay, and its equivalent value is given as 13.6 electron volt. Okay, we will be concerned with this value, 13.6 electron volt. Okay, intermediate step is just for our knowledge and understanding. It will not be used here. Okay, next snapshot is about En equal to minus E square over 8 pi epsilon naught Rn. This alternatively becomes equal to minus E square over 8 pi epsilon naught A naught N square. Okay, dear students, here A naught is Bohr radius. Okay, this alternatively becomes equal to equal to, there are three straight lines. Okay, one is the sign of equality and one straight bar is written above sign of equality. Okay, this is Read as this is treated as is equivalent to or is defined as. Okay. Dear students, we are seeing that before these three lines there are two sign of equality. This sign may also be treated as a sign of equality, but it is much better if we treat it as equivalent to or defined as. Okay, so E naught is equivalent to or E naught is defined as En. En is equivalent to or En is defined as E naught minus E naught over N square. Here N is the energy level. Okay, the lowest energy state N equal to 1 is E1. So when we put N equal to 1, then E1 will become equal to minus E naught. Okay, because 1 square is 1, and so E1 will become equal to minus E naught, where E naught is equal to E square over 8 pi epsilon naught A naught. This alternatively becomes equal to E square over 8 pi epsilon naught into 4 pi epsilon naught H cut square. Okay, this is equal to E square over 8 pi epsilon naught into me square over 4 pi epsilon naught H cut square. This alternatively becomes equal to me raised to the power 4 divided by 2h cut square into 4 pi epsilon naught whole square, and this is equal to 13.6 electron volt. Okay, so dear students, after introducing these snapshots, now we are going to start our solution in a regular manner, in a formal manner. Okay, E is equal to HF. This is equivalently equal to HC over lambda. Okay, the first snapshot in which energy of a photon was discussed, this expression was given. In the second or third snapshot in which a table of physical constants was shown, it was emphasized that in that table not only value of speed of light c is given, but also value of Planck's constant h is given, and also combined value of hc, that is after multiplying Planck's constant h with speed of light c, is also given. Okay, so dear students, from that table we will take the combined value of hc as 1240 electron volt into nanometer, while value of wavelength lambda is provided in the statement. Okay, so we will take the value of lambda from the statement, which is 95 nanometer. Okay, so in the numerator there is 1240 electron volt into nanometer, while in the denominator there is 95 nanometer. Okay, so nanometer will be cancelled with nanometer, and we will be left with the answer 13.05 electron volt. Dear students, this is the value of E. Okay, this is the value of E, while expression for En is given as minus 13.60 electron volt over N square. Okay, dear students, we have calculated the value of E, while in the next step we have just put the formula which was shown in snapshots in previous steps of this problem. Okay, En is equal to minus 13.60 electron volt over N square. Okay, dear students, now what will be our methodology? Now dear students, in this equation we will put n equal to 1, then n equal to 2, then n equal to 3, then n equal to 4, then n equal to 5, then n equal to 6, then n equal to 7, and then we will analyze difference of two levels. We will see which difference becomes closer to this value 13.05 electron volt. Okay, So dear students, when En is equal to this, then E1 will be equal to minus 13.6 electron volt, because 1 square is 1, so E1 will become equal to this value. Okay, so E2 will become this value divided by 4, because square of 2 is 4 and this 4 is in the denominator, so this value will be reduced by fourth time. Okay, E3 will be E3 will be this value divided by 9, because square of 3 is 9. This value E4 will be this value divided by 16, because square of 4 is 16. This value, that is E5, will be this value divided by 25, because square of 5 is 25. E6, this value will be equal to this value divided by 36, because square of 6 is 36. So we have found these values of E1, E2, E3, E4, E5, E6. Okay, dear students, keep in mind that we have to make a comparative relation with this value 13.05. 13.05. So dear students, we say that now E minus E naught is equal to this, which we have calculated first of all. Okay, E minus E naught, this is the value of E naught which has been shown in snapshots. Okay, so E minus E naught becomes equal to this minus this equal to this minus 0.55 minus, oh yes, there is a minor mistake, minor. The only minor mistake, that with this 0.55 there should be electron volt, but perhaps only numerical value has been subtracted, unit has not been written mistakenly. Okay, so this is minus 0.55 electron volt, and this is approximately equal to E5. Okay, dear students, we see that E5 is equal to minus 0.54, while we have to found that state or level in which difference is exactly same or very close to this. So dear students, minus 0.54 is very close to this value, so we will adopt this E5. Okay, so our answer will be, hence initial and final states are n equal to 1 and n equal to 5. Okay, because E5 is the value which makes these adjustments. Okay, now this is the end of our problem, this is the end of our video. Till next video, Allah Hafiz.